So this session is a little bit about my experiences in using Lava V2 pipeline for KVM testing, and the second half is then a little bit more of planning how we should proceed forward and what people want from KVM testing. The background is that Lava has had the VM group feature for supporting KVM and QEMU testing. We've also been testing KVM manually by running some commands and then doing some hacks to get inside the VM shell. The VM groups are easy to use if they are good enough for you, but they're also somewhat restricted. You can only start the VM using the commands that are in the Lava definition, Lava type device definitions. You can't use Xen or libvirt or anything else to start the VMs or use some exotic options. So the go-to answer for any problems you had with the V1 Lava is that just wait for Lava V2. And finally, we are starting to have it here. The pipeline, as it's also called, has explicit controls for everything. That's the promise. Not always been true, but quite a bit better than V1. During the summer, and we've been working with Neil a lot to get pipeline into the state that I can use it for KVM testing, and thanks to the pretty quick responses, most of the bugs have been ironed out. Actually, I don't think we have any open bugs related to KVM testing now. And if you haven't heard about Lava V2 and you intend to use it, tomorrow there's a training session. I unfortunately should have probably asked people to change the schedule the other way around, so I wouldn't have to take so much time to explain about pipeline. I would heavily recommend the training session if you want to use Lava V2. So I have a basic test here. Let's zoom a little bit. We start with the host deployment section, where we boot a kernel directly out of the kernel CI storage. The definition here is defined for NFS booting from TFTP, so we don't need to install anything on the hard drive. This doesn't really have any differences for a typical pipeline job except for the role host part, where we tell that this is actually the host that is going to boot. There are roles defined for this kind of multi-node job. We have the guest job, which will be connected to over SSH, and we have the host job, which will be a Mustang and ARM v8 hardware, which is quite capable of testing KVM. There's lots of memory and quite speedy CPU. Also the only enterprise hardware we have at the Lava Lab currently.
Can you explain what you did with the init RD, what you needed a custom one there?
Good question. So there's a custom init RD here, and it's a very, very simple BusyBox-based init RD, which only sets up the network interface in bridge mode. We want to use bridge mode in the init RD because if we switch to bridge mode when the system is already running on NFS, we will lose the root file system. And we want to use the bridged mode for KVM testing because the user mode networking in QEMU and KVM is rather slow and not very useful direct as it is. Also, we wanted to give a direct IP for the guest, which is not possible with the user mode QEMU. I mean user mode networking in QEMU. User mode networking in QEMU is based on Slurp code, which is like from 90s or something.
Have you considered adding a network interface? To have one interface for rootfs and second for just bridging?
You mean an alias?
No, just physically second. So you
to two Ethernet networks, basically.
Yes.
I don't know, actually. Is the second Ethernet port connected on the Mustangs on our Lava Lab?
So it's quite interesting on Mustang. So there's 3 Ethernet interfaces. Only one is usable because the driver is completely dead for the 2 others. And most Mustang come in a 1U rack without any 90-degree angle bracket. So if you want to cut the enclosure to put your PCI card in, that's fun, but only limitedly. So no, it's pretty hard to do, actually.
Which Mustang? I've got Mustangs in Austin that I can use all. I have Mustangs in Austin that have 3 gig interfaces that
do you
are
have
usable.
all 3 interfaces up and running with mainline? I'm not interested in anything non-mainline. So if it's I don't know, some fancy kernel that comes from I don't know where.
It's not. It's our enterprise. It's our 1606.
So as far as KVM is concerned, there is mainline, and there's nothing else. Thank you.
Yeah, so if you are more interested in how it works, there's the code available on GitHubs. It will use a switch root in the very end. That's the build script. Up.
So the reason I'm interested in that, Riku, is because in kernel CI, we have a problem right now where we actually need to probe network module before we switch to NFS through. So this is going to be perfect for this.
Currently, this expects for NFS the Ethernet module to be built into the kernel, but it's just a few extra shell script lines here. I understand that Stephen McTire has been doing the same thing for initramfs tools, but it didn't work for me, and the initramfs tools, it was just too complex, and I needed to quickly write something that just works. Where's the other mic?
Yeah, so I had a hacky solution in initramfs tools, but it wasn't clean enough to be able to push it upstream. Talking with Anders in LNG, he ended up using your script, but has just tweaked it to force load all the Ethernet modules before it switches.
Okay, so there's another guy who needs the same feature.
Yeah, and that seems to be working absolutely flawlessly for him.
So we were looking at the pipeline jump definition, and for the guest role, we don't have any kind of boot definition in the terms of kernel or anything. We just tell that it's an SSH-based boot, so it SSHs inside when it gets the lava message of the IPv4 address of the guest. Then we have the test definitions. Here's the host part of the definitions. We first run just some basic smoke tests for finding out that the host has booted properly. And then we run the KVM starting test definition, which we give parameters of an ARMv7 cloud image. So we are booting, in this case, an ARMv7 guest on an ARMv8 host. The test definition has been parameterized so that if you boot an 64-bit image, you will not give a kernel, like in this case, there is a kernel for the ARMv7 case. We don't have a UEFI available for ARMv7 KVM booting, and the U-boot work is still under progress. And the role guest is the tests that will be run inside the guest. So we can see that it's rather neatly. We just need to give similar test definitions. It's not like the old job where there were hard-coded tests to run inside the guest. You can just choose any test you want to run inside and outside the KVM. For example, if the smoke test would give a performance number, you could then compare the performance that happens inside the KVM and outside the KVM to see how much performance is being lost. So here's a quick graph that tries to explain what exactly is happening in this test definition. Lava is the Lava dispatcher here, which loads the kernel and asks the Mustang to boot. The Mustang will then run the host tests that were defined in the test definition earlier, which will then start QEMU, which makes a guest available. Now that the guest is available, we need to somehow get the IPv4 address of the guest out, and the guest will tell it to the host, which will pass it down to the Lava dispatcher. Now the Lava dispatcher knows where to find the guest, and it will SSH inside, finally to run the guest tests. For the guest deployment, we first download the kernel, if it's an ARMv7 system, or just the image for the root file system or the cloud image, and boot that one directly. Currently, the test definition will also download an EFI firmware, but it will be probably modified to use the EDK2 packages that are now available in Debian. So there will be one less moving piece in the tests. To configure the guest, we use a very versatile tool called Cloud Init, which will let us explain how to get access to the job, how to configure the guest. The cloud config will create a user named Linaro and add an SSH key for it. It will be the Lava key text. There will be subsized, overwritten with the actual SSH public key. We tell it we have a sudo access, and also we give directly the same SSH key to the root user, because Lava will log in as root. I'm not sure if Lava has possibility to log in as user yet.
I can look at that. I don't know. I don't think it does yet. If we have we can make that configurable, actually, probably.
I'm not sure if it would make it cleaner or not. And as we see, the cloud config can allow you running arbitrary commands on the first boot of the image, and finally it will be able to phone home. It will make some kind of HTTP request to the URL where you're connecting. In this job, we will give a URL of the Mustang machine where we will have an HTTP server listening for the IP address. For the actual command that is going to be started is included in the test definitions, and the command line is getting quite wieldy already, even with such simple setup. So it's no wonder that people are moving to use libvirt and other tools to make these things automatic for you. If you want to modify this test case, this is probably the place where you're going to be working to change some kind of different command line to boot your guest image. The actual images that are downloaded were given in the job definition earlier. One thing about the cloud init is that it has image that's supported in all cloud images provided by various distributions. Ubuntu, Fedora, and CentOS have images with cloud init. I haven't yet tested Marcin's images, but I think they have cloud init available also. So once the KVM has been started, we need to start giving a signal to the Lava system where we are. And down there, once the script to start KVM has been run, we first use the lava send command to give the IPv4 address we have just received from the script that has been waiting for the IP address. This is one of the parts that I don't really like about this job, that I have embedded this into the test definition, that instead of using the inline definitions as has been recommended in the Lava documentation, the problem is that I currently need a script to get the IP address, and having the access to the script from inline is tricky. After we have got the IPv address and sent it to dispatcher, we send the Lava start message, which will then cause dispatcher to start the access. I'm not actually completely sure what the Lava Sync client is doing, but
that's there to make sure that the underlying Mustang keeps on going and waiting until all of the various clients have finished. So if you had more of these.
So it's basically waiting for the guests to finish, because we get the Lava Sync client from the guest test definition as well.
Yeah. Otherwise, your Creamy will suddenly disappear because the device underneath has been turned off.
So we have a stop guest job that is then analogous to the start one that will just give the Lava Sync to tell that the job has finished. And if you want to learn more about the job, the Lava synchronization signals, you have to look at the Lava documentation. So a little bit about the multinode protocol. We have to define here what is the exact message that we are expecting, and then we have to send it in the same format. Here we have told that the guest is connected via SSH once we get the IPv4 address, and that at that point we will install the Lava overlay with SCP. One of the confusing parts here is that you can use the multinode protocol bits both inside the test definitions, whether they are inline or ones that are cloned from Git, but also in the actual job definition, and the semantics are not exactly the same. Usually they are, but keeping up to date with this all is slightly complicated. I don't think it's a problem because doing multinode testing is going to be complicated regardless. So once the job has finished, we get the results up in the validation Linaro org, and there's different set of results for the guests and different set of results for the host. For, I think, Christopher's use cases, we would like to have some kind of custom user interface that shows more directly exactly the things that you're interested in. Yes, of course, we would need to download it from Lava.
That's a need outside of Lava. So those buttons right there, CBS and YAML, so you can just pull that straight and parse the YAML out for the results. So that's how external systems can grab that pretty easy. You just need the job ID.
So a little bit of the experience here. If you were looking at my test job, you might have noticed some odd timeout values. Each of the timeout values I wrote was unique, so it's easy to see from the log which exact timeout was the one that tripped over. It's kind of making a unique key. The V2 jobs have lots of timeouts everywhere, and figuring out exactly what one is too short is sometimes annoying.
Riku, just here. Just a comment about the timeouts. We just added a new page on the job when you're on the validation.linaro.org. On the job, you can have timings. You will have a list of all the actions of the pipeline, and for each action, the time that it took to run on your job. So you can inspect and see if you need to change your timeouts easily, like with this.
Okay, sounds very cool. Does it have some kind of feature to show that, say, in a yellow or red color when it's getting rather close to the limit, and green if it seems it was well enough?
No, there is not, but it's interesting, yeah. There is two colors, red, which is for the longest action,
yeah.
and orange when it's just above the mean time for each action. But I can look at looking at the difference between.
This was just a quick idea, so.
Yeah, that's a good idea. It's for the next release.
Yeah.
It's in staging, not in validation.
So are you planning to run some usability tests on daily basis against Linux Next or something?
So basically I'm hoping that I can wire this into the kernel CI, so after the KVM job has the one that is included in kernel CI has successfully booted, then we can start this as a second stage job that runs more complicated test cases.
Hey Rico, have you tried Zen with this yet, or is it just QEMU at the moment?
I've tried only KVM, and recently I've been started testing with libvirt as well, since there was an interesting case where people were unhappy that I upgraded libvirt in overlay and it didn't completely work. So one of the coolest features of Lava v2 is that you can have test definitions integrated directly in the job definition, and these are really useful in getting things quickly developed. Use them if you are using v2. And while I wouldn't say that it's that much beta code Lava Dispatcher anyways, the fact that it's open source and you can have a Git checkout of it makes things a lot easier for finding out when things don't go as expected. Yeah, well, the documentation is always a little bit lagging behind. And in many cases, the best way is to just try and see if it works, and if it doesn't, then start screaming around rather than first asking everyone how things should be done. It's easier to figure out by just trying around.
And easier to find new bugs.
That's, yes, definitely. People will tell you if you're doing things wrongly, or Neil will tell. So the future is to extend this to do more tools, libvirt, because people are depending more and more on it. And Xen was also mentioned that people want to see that one. And KVM tool is popular with the kernel developers, so I guess they would like to see it tested with this as well. And some kind of web front end to make the results more digestible for our KVM and Xen developers. The Lava interface is rather raw. And the interesting test case is what people actually want to run inside KVM to find out what are the test cases that you're interested in.
Well, basically, anything you would expect to run on the host. I mean, if we're talking about servers, I would love to see an Apache server and then some netperf or something like that. I mean, anything that would be representative of a normal server workload that you would deploy in a VM. Yeah, it's not a lot, but that's still quite a lot actually.
One of the examples that's interesting from my perspective is that we stress test our own code with functional tests, and one of those is to run the Lava server unit tests inside a QEMU that's actually running on the dispatcher. That's actually quite a heavy workload because it involves Apache, it involves WSGI, it involves Postgres, and then you're stress testing a whole range of dependencies. So there are jobs like that we could actually port over. And
yeah, so if you could move your whole Lava framework into the VM, yeah.
It's trivial because we'll be just testing the version that's in Debian, and we just pull it down from Debian and run it.
Yeah. So just make a Lava test shell definition out of that, and you can run it already with these tests.
Exactly. It would be a trivial thing to actually just port what we've currently got that just boots a standard AMD64 QEMU, and we can port it directly to this as a
well, let's try it.
And so basically you can test any test we have in QA test definitions already. And if it's not in QA test definitions, we should add it there. Now that we have this freedom of doing pipeline tests, I think one of the interesting test cases we want to have is migration tests. I did a manual test in Lava by reserving 2 hacking sessions, and it seems to be possible to do very easily with libvirt. The key challenge is to have some kind of shared storage for the images. So we need a third node where we run Ceph. One annoying thing one thing that annoys me is that we only have Junos and Mustangs of hardware that is relevant for KVM testing, while we have, for example, many other V8 server hardware, and we have no idea if KVM works with them. Okay, cool. It's a good start.
So obviously, from our point of view, I think yeah, it's great if there's more hardware, but I mean, as long as we can do something on Juno and Mustang, that's a good start. We don't have anything automated that covers enough today, so just doing something on the hardware we have is great. I think another thing that's missing here should be when you actually run VMs, right? There's a multitude of configuration options, SMP, non-SMP. We've just seen issues on the mailing list about you running the IRQ chip in user space versus running it in the kernel. So all these kinds of options are things that we've historically seen continuously breaking. So figuring out all the knobs you can tweak in terms of how to run KVM, which turns into some sort of matrix, and try to cover as much as that with a simple test. I think that's probably the third bullet instead of the third that's there. I mean, I think it's more important to get that covered than running very advanced tests inside, at least from my point of view, because that's the really hard point to do manually for me and Mark when we're developing, because we can't spend 6 hours just running hundreds of scripts with all sorts of different configuration options. So yeah.
So we need some kind of fuzzing script to run QEMU with all possible options. That's one of the things why I think using libvirt is very important, because that's what a lot of people will end up using. And finally, we had the phone home feature that was used from Cloud Init to talk via Mustang to Lava dispatcher, and I've been thinking that this would be a nice feature to have directly inside Lava, that this is a Cloud Init image, please configure it like this, and when it contacts you from this IP, we know it's a Cloud Init based image. If you think it's okay, I will write a more articulate bug report out of this. So any other questions?
So have you actually tried anything with libvirt? The reason I ask is, so usually we just run QEMU directly, but for all my x86 VMs with KVM, I use libvirt, and then I tried, so the other day I said, okay, it's time to try just installing a recent Debian, a recent Ubuntu, just using the normal tools, virt install, verse and stuff, and then nothing worked, and I just got obscure errors and segmentation faults, and then I was wondering, so I heard that this all just works on a recent Fedora, for AR64, but maybe I'm doing something wrong, or I need a specific overlay or something. So does anybody have input on this?
Well, I tested recently Ubuntu Xenial 16.04. It was working just fine.
On which distro?
Ubuntu, latest LTS.
Okay, all right.
It also works fine with Fedora 77.
Okay, so yeah, I must be missing some sort of foo. All right, I'll get in touch with you guys when I'm trying again.
Yeah, yep. There's a known bug.
We did update the libvirt to 2.1 in the overlay, and now it should be working. And well, I think they used that specific libvirt in the test the demo they were showing on Monday morning in there. So underneath OpenStax. I did quickly test libvirt myself. I'm not sure if the commands are exactly the same you use on x86, but it did work for me, and I was even managed to migrate an image from one Mustang to another, which I was not able to figure out how to do with plain QEMU commands.
Basically, the idea of libvirt is to have one interface on all architectures, and never mind which hypervisor is under. So you can use vir.sh, for example, vir install with KVM, then Hyper-V probably also.
even libvirt it has lots of permutations. You can use direct disk images from NFS or ZEPFAN. So there's probably always going to be corner cases that we don't remember to put into our test matrix. So I guess that's all from this time, and does anyone have more questions? Thanks everyone from the Lava and KVM team.